everyone. This playlist is going to take you through page 8, which fortunately is a little bit less intensive than some of the other pages we've been doing lately. It only has 2 questions on it. So the hopes is that not only will this playlist and its videos be shorter, it should take you a shorter amount of time to work through these questions. This is the last new lesson of the week because, as you may remember, we have a scheduled holiday on Friday, which means that there will be no work assigned that day. And that means that page 8 is really the last page to complete the learning plan for week 31. So that should give you a nice way of kind of easing your way out of this material so that you can close out the week and finish the work with a little bit less of a time-consuming task ahead of you. I'm going to do parts of question number 4 to just make sure that you have a good example to follow, and you'll be on your own for question number 5. Both questions are very similar though, so figuring that we can do question number 4 in a video is going to give you a good foundation and some notes that you can use to compare it to question number 5 on your own. In question number 4, we're basically going to do the exact same thing that we were doing on the previous page. So if you watched the videos that went along with page 7, you probably already kind of remembered that we came up with a strategy for finding the adder when you're given only a couple of terms but a bunch of missing spaces. And we're going to recycle that strategy on page 8. So if you haven't yet, make sure that you've watched and understood the videos for page 7 so that you can have that formula under your belt. That formula where we subtract t of n, subtract n, and then divide is definitely going to come in handy on page 8. Now, in order to set up this problem so that it reminds us of the formula problems that we were doing, let's read the question and just make sure we understand what it's asking, and then we'll try to draw some parallels to what you've already seen. It says in question number 4 that Frank saves the same number of bottle caps each week. After 3 weeks of saving, he had 33 bottle caps, and after 7 weeks, he had 53 bottle caps. So in letter A, it says, although this problem doesn't explicitly say so, how do we know that this scenario is arithmetic? And it is interesting that they never said it's arithmetic, but hopefully your gut instinct is that it is. Now for me, the key phrase was that phrase right there at the very beginning where it said he saves the same number of bottle caps every week. That to me was the dead giveaway that this is arithmetic, because if he's adding the same number to his collection every single week, that is the very definition of arithmetic, when you're adding the same number every single time. So if you want to put this in your own words, then you can take a second to write in letter A whatever you want to write, but that to me is the clue that gives it away. It's the fact that he saves the same number of caps per week that tips us off. Now, let's see if we can make sense of that the way we would have done some of the previous questions on page 7. If we think about this given information, I'm going to set it up just like I would have set up those other questions on page 7 so that it rings a bell, so that it triggers that part of my brain that's like, oh yeah, right, I've seen this before. It says after 3 weeks of saving, he had 33 bottle caps. So 3 weeks is kind of telling me that he saved for 1 week, he saved for 2 weeks, nope, he saved for 3 weeks. So N is kind of like the weeks here. And he had 33 caps. So that tips me off again that I can set up my table very familiar in a way that I know I recognize. The third term is 33. So then he must have saved during his 4th week and his 5th week and his 6th week, so that after his 7th week, he had 53 bottle caps. So notice I filled in that table again. The reason I did it this way, though, is so we could use that strategy that we used on page 7. Remember that highlighted formula where we said we could subtract t of n on the top of a formula, we could subtract n on the bottom, and then we could divide? I think that's going to work perfectly here. Let's see if we can make it happen. If I subtract t of n, that means subtract these 2 bottom numbers. 53 minus 33. The order doesn't matter, so you can subtract whatever you like. I usually like to do right minus left. Then when it says subtract n, that means subtract the top numbers in the formula. And again, you just have to be consistent. So if I did right minus left the first time, I'll need to do right minus left again. 7 minus 3. Now I'm just going to quickly see if I can do that math in my head. 53 minus 33 would be 20. On the bottom, 7 minus 3 would be 4. 20 over 4 is 20 divided by 4, which is 5. That must be my adder. So I've done enough problems to know that when I need to find the adder, this formula is going to do the trick. So that must be telling me that's the pattern. That's how many caps he must be adding each week. Let's make sure that the adder really is 5. Let's make sure that it makes sense before we commit to writing this as my answer. If you really did save 5 caps per week, then 33, the following week he saved 5 more caps, that would be 38. I'm just going to write it kind of small. Then if he saves 5 more caps, that gives me 43. Then if he saves 5 more caps, that gives us 48. And then if he saves 5 more caps, yep, that's 53. So it does look like this really does work for his pattern. Now I'm going to write my answer for sure in question letter B, where it says how many bottle caps did he save each week? He definitely added 5 per week. So here's where I'm going to turn the challenge to you. How can we work backwards to figure out how many caps he had initially? Initially means the initial value, or the 0 term in the table. Can you work backwards now that you know that the adder is 5, and can you figure out that initial value? I'm going to ask you to do that between now and the time the next video begins. Try to find the initial value by working backwards and figuring out what number needs to go in this missing yellow highlighted spot. In the next video, I'll tell you what I got, and we can compare to see if you got there on your own correctly.